Right, good afternoon and welcome to the Oxford Martin School. Welcome to the second of our series on shaping the future. This afternoon we have Professor Jim Hall. Jim is Professor of Climate and Environmental Risks at the School of Geography and Environment. For 8 years he was Director of the Environmental Change Institute here at Oxford. His research focuses on management of climate-related risks in infrastructure systems, in particular relating to various dimensions of water security, including both flooding and water scarcity. He's a member of the UK's Independent Committee on Climate Change Adaptation, Fellow of the Royal Academy of Engineering, and a contributing author to the 4th IPCC assessment. He leads the UK Infrastructure Transitions Research Consortium, which has developed the world's first national simulation models for appraisal of infrastructure investment and risks. So we are in good hands for tonight's question, whether we're on the road to somewhere, for Jim to tell us about resilient infrastructure for sustainable development. Thank you, Jim.
Thanks very much indeed, Julian, for that introduction, and it's a great pleasure to be here. The title of my talk betrays the fact that in my youth I was a big Talking Heads fan. I still am, I suppose, and by twisting their anthem of a road to nowhere, I'm trying to kind of draw attention that the notorious power plants and highways, which we see as being part of the problem with respect to sustainability, may also be part of the solution. But having settled on this title, a couple of weeks ago I came across this book and by David Goodhart, who got there first, so clearly Road to Somewhere is not going to be the title of the book I'm writing at the moment. David Goodhart's book is not about infrastructure, as the subtitle indicates. It's about the politics of place. But as we saw in the election campaign and subsequently in this government's priorities, actually infrastructure has quite a lot to do with the politics of place at the moment. How we invest in transport for the north, whether HS2 should go ahead or not, how do we provide 5G coverage universally. The fact that infrastructure is deeply political is nothing new. It involves deploying very large sums of capital. There's plenty of opportunities for political patronage and corruption even. And this issue of The Economist in 2017 discussed the role of infrastructure, amongst other political interventions, policy interventions, in addressing disadvantage and political malaise in America's Rust Belt and in the north of Britain. One of the conclusions of this analysis was that infrastructure on its own is not enough to address the economic shifts which are brought about by globalization and changes to industrial structure. In fact, the economic geography of Paul Krugman and Tony Venables here in Oxford illustrates that all other things being equal, if one has comparative advantage over another, financial services in London versus the north of England, then creation of better connectivity will advantage the south rather than the north. And it takes a very big push to shift that into another equilibrium. So what this issue of The Economist went on to argue is that infrastructure on its own is not enough. You need a set of complementary policies, including skills, education, housing, alongside infrastructure, if you're going to have any hope of shifting the economic geography. Similar questions around the relationship between infrastructure and the economy come from this picture here. This comes from, along the bottom here, we've got the World Economic Forum's score for the quality of infrastructure. On the top, we've got, on the vertical axis, we've got GDP per capita. The World Economic Forum's infrastructure pillar raises a whole load of questions. People joke that it comes from asking questions to businessmen who travel through an airport to a capital city. There is more data to it than that, but there is some subjective surveying. What you see, though, is that there's clearly a relationship here. The big question is, which direction does the causality go? Does infrastructure lead to economic development, or does economic development provide the resources for infrastructure? And the answer is, of course, it goes in both directions. What the picture also shows is that there's a great deal of scatter. There are plenty of opportunities to get infrastructure wrong, even in relatively rich countries. This is the notorious Ciudad Real airport near Madrid, €1 billion more or less of investment, and it went into bankruptcy a few years after being opened. And infrastructure overinvestment has long been associated with indebtedness. There's growing concern about countries that benefited from debt relief in the past taking on unsustainable levels of debt again, much of it associated with infrastructure investment, the terms of which are not entirely transparent. Now, you may be asking yourself by now why someone who works in the Environmental Change Institute is talking about the politics and economics of infrastructure. I've probably spent more time than I'm qualified to do laboring the points I've just made. But I'm doing that because I think our determination, and here I speak of mine and many of the colleagues that I work with, to address the urgency of the climate crisis needs to be in the context of the recognition that most of the infrastructure development taking place around the world is motivated by economic development. And there are some who would wish that reality away. Personally, I think we need to engage with the economics and the politics of infrastructure development to try to identify the points of leverage and shift those choices towards sustainability. At $2.3 trillion a year, infrastructure investments at an all-time high, and those choices which are being made now are locking in patterns of development for years to come. And yet, despite that level of infrastructure investment, we don't see the quantity, quality, affordability of infrastructure services that are needed for sustainable development. Now, there are many reasons for that. Weak governance, political attraction to vanity projects and extracting rent, inadequate maintenance of assets, insufficient availability of capital at the same time as unsustainable levels of debt, repeated damage to infrastructure by natural hazards, and simply poor people being too poor to be able to afford the infrastructure services that they need. And all of those, one might think, are fairly old chestnuts in the, at least in the development economics literature. But I think there are some new ideas and opportunities which are shaking up that debate. One is the recognition of the need for systems approaches to deal with the interdependencies between different infrastructure sectors. The fact that infrastructure is increasingly interdependent, interconnected, and converging, in particular because of the role of digitization and electrification within most infrastructure sectors. There's a renewed emphasis on upstream infrastructure planning. This went quite out of fashion because planning was regarded as being dirigiste, almost Stalinist, but actually the way in which infrastructure planning, and I think in particular about the role of the National Infrastructure Commission in this country, is being thought of is much more now a process of exploring scenarios and developing adaptive strategies for investments and policy interventions in infrastructure systems. There's a growing recognition of the ways in which climate change is undermining the benefits of infrastructure investments, undermining sustainability, as well as vice versa, that infrastructure itself is contributing to climate change. And there's a revolution going on with respect to infrastructure data so that we're much more able to pinpoint what's going on, what services are being delivered anywhere on the planet. These shots here come from work by Steve Rees here in Oxford, who's using Earth observation to look at the damage to infrastructure assets during earthquakes and use that to inform disaster risk reduction. And there seems to be a growing appetite amongst our partners in the World Bank, the UN, the Global Commission on Adaptation, to recognize the imperative of sustainable infrastructure. The SDGs provide a much more comprehensive framework for thinking about the role of infrastructure in sustainable development than the Millennium Development Goals did. Last year, some colleagues here in Oxford and then a number of partners within development agencies and development banks, we published this analysis of the role of infrastructure in helping to deliver the Sustainable Development Goals. And the headline there was that 121 of the 169 targets which go to make up the SDGs are either directly or indirectly influenced by the provision of infrastructure services. Some of those are quite obvious. SDG 6 and water, that's the blue one there, is entirely dependent on infrastructure services. SDG 7 and energy, SDG 9, which is industry, innovation, and infrastructure. So no surprises there, but then right across the piece, we see the role that infrastructure has, for example, in providing information, enabling people to access services and participate in government. And yet, on the other hand, we recognize that, as I said at the start, infrastructure is part of the problem as well as being part of the solution. Inappropriate infrastructure development appropriates land, fragments habitats, excludes the poorest, and locks in carbon emissions. What we identified in the analysis with respect to the SDGs is that not only does the right type of infrastructure enable one or is necessary in order to deliver the SDGs, but the targets within the SDGs provide a series of guidelines and rules by which one can ensure that the infrastructure that is provided is sustainable. So the SDGs help to safeguard against the harmful impacts of infrastructure provision and ensure that the benefits of infrastructure are distributed equitably. What this analysis really demonstrates is how multifaceted the many roles of infrastructure actually are. And so when we engage with decision makers around these problems, we find them asking these types of questions. What do we prioritize? How do we provide services for everyone? Where do we start? How can we harness innovation and make appropriate use of the market? And the way in which we've approached answering those questions within my group has been through development of systems approaches. That started with a large EPSRC program, which this book came out of, which led to the development of the NISMOD, National Infrastructure Systems Model, which Julian referred to as an introduction. NISMOD was used by the National Infrastructure Commission for the National Infrastructure Assessment, and very recently we've used it for analysis of infrastructure provision in the Oxford-Cambridge arc. The way in which that we structure the problem using NISMOD, and these next few slides will come from collaboration with the UN Office for Project Services, begins by looking at what's the current state of infrastructure and the services that it's providing. How does that then project into the future, given the changing nature of demand for infrastructure services, changing population, economic structure, climate, and then given that baseline projection, how does that compare with the level of performance which we might aspire to based on the SDGs? And usually there's some gap there. So the question then is, well, what combination of interventions, both of investments and policies, can one implement in a staged way in order to build a sustainable infrastructure strategy which takes you towards your goal? And a series of tools have been developed within NISMOD in order to help to inform that type of analysis. The latest version of that was done in Saint Lucia, and colleagues were out there just last month, where a national infrastructure planning and program unit was established within the finance ministry. And in many senses, small island states are a good place to do this kind of thing because governance is quite concentrated, hierarchies are quite flat. In many other parts of the world, the biggest obstacle one comes up against is who actually owns this problem, because one has very siloed sets of ministries which seldom talk to each other. So there's a real struggle to develop the type of systems approach which we're promoting. But within Saint Lucia, we managed to work very quickly to develop a set of geospatial data sets, implement a version of the systems modeling, and then move to use that to develop pathways towards sustainable infrastructure. And that came in two parts. One was this question around what's the national vision for infrastructure service provision in the future, how are needs going to evolve, and what are the options for us to address those needs. And then the flip side is the resilience and adaptation question. So how vulnerable might those assets be to climatic extremes? And there are many of those: sea level rise, storm surges, flash flooding, landsliding within Saint Lucia. So then how can those investments be made more resilient to those growing threats in future? And the type of framework which we use for doing that is to begin by looking, as I say, at this baseline. This is the baseline projection with respect to the electricity sector in Saint Lucia. So currently more or less completely dependent on diesel generation, upward demand, so the capacity margin, the security of supply potentially going down in future. And then we begin to look at, well, what's a realistic stage sequence of investments which enable to improve security of supply and the transition towards renewables, which the island is committing to in its commitments with respect to Paris. And you can see that in this timeline, we gradually tick off SDG targets as we progress through time. And you can see how the national strategy that was developed compares with respect to the baseline and inaction in the 2030s and 2050s. Similar exercises were done with respect to solid waste, looking at the SDGs goals with respect to the circular economy, the transition from landfill sites, which were rapidly getting filled up. That's the red dotted line, which is plummeting downwards to a whole series of more sustainable solid waste management systems, which is a real problem on small islands. In wastewater, a similarly staged strategy, this is water supply strategy to improve security of supply with respect to water provision, and with wastewater, again, a concerted effort in order to address the untreated discharge of sewage and a move to more comprehensive wastewater treatment in the future. And then within that, we were able to look at the interdependencies and some of the major drivers which come in particular from the growing tourist industry and the demand that is producing on infrastructure services across the island. And together, that strategic approach enables us to demonstrate how Saint Lucia can, if it moves in a staged way, achieve its commitments with respect to the Paris Agreement. That's all fine, unless there are climatic extremes which might destroy or disrupt some of those sustainable investments. So then we come to the flip side of the sustainable infrastructure provision question, which is how do we make systems more resilient? And the way in which we address that is by identifying what is the climate risk at the moment, where is it located, how is that changing, how much it might increase in the future, and then what are the cost-effective adaptation options. There's a revolution underway in terms of the data sets which we can access in order to address these problems. The snapshot on the left comes from a paper we published in Nature Communications last year, which was the first global assessment of transport infrastructure vulnerability to natural hazards. So you can analyze, here we analyze 60 million kilometers of road and rail data around the world, used global flood hazard data in order to identify where the greatest vulnerabilities are. And then the panel on the right is a combination of real and synthesized data of all of the global electricity supply and transmission infrastructure. So there's incredible capability now for us to analyze risk to infrastructure at a large scale. The assessment framework, which that then leads into, and combines mapping of where the hazards are located, where are the infrastructure networks, if those networks are disrupted, how might flows of traffic, of energy, of water be rerouted through the network, and then what are the economic consequences of that disruption? Because understanding the economic consequences in the baseline case, in the do-nothing case, is essential to then enable us to calculate if we do something, if we strengthen the network, if we make it more resilient in some senses, what's the benefit, which is the difference between the risk in the do-nothing and the residual risk if we do something. And so we can then rationally begin to weigh up costs and benefits of adaptation in order to prioritize interventions. We've done a series of studies at a national scale on this. The first was in Tanzania, and Raghav Pant, who's here, did all of this work. First of all, looking at the hazards of the risk of flooding, then looking at how that flooding might change going into the future. The next thing is then looking at the vulnerability of the transport network. So how much is flowing through the network? Where are the most important points in the network? And how is that projected to change going into the 2030s here, given projections with respect to the economy and population. And then now we switch to two other countries we've worked in, Vietnam and Argentina, where there we were able to calculate the economic consequences. So these are using all of these calculations, but millions of calculations of disruption, rerouting, the cost to businesses and the economy of those delays and rerouting, in order to pinpoint where are the points in the transport network where you might get the greatest economic loss from disruption. And you can see on the scale there, we're talking about losses of millions of dollars per day for disruption at the most critical points in the infrastructure network. The next question then is, how might we respond to that? Some of that is fairly conventional engineering. Some of it is accessing the benefits of nature-based solutions with respect to, for example, slope stabilization and dealing with runoff and drainage issues. And that then becomes a question of weighing up those benefits of risk reduction, which is on the top part of the scale here, with not only the cost of implementing those interventions, but also the ongoing maintenance cost and the occasional periodic maintenance costs associated with those interventions. And I mean, we have to be completely honest here that strengthening infrastructure and networks in that way is not cheap. And so this is why we have to work very hard to make sure that the case around adaptation is very rigorously made. And we can do that type of calculation to then, again, pinpoint in the network where are the most cost-beneficial places to intervene, as we have done in Vietnam in this picture. The panel on the right shows benefit-cost ratios. The red line is 1, so it's only the stuff above the line which is actually worth doing in simple economic terms. But we can see exactly which of those assets we should be prioritizing if we have a limited budget in order to strengthen and enhance the resilience of that network. There are a bunch of uncertainties in there, and so sensitivity analysis has been an important part of what we've done here. We're looking at two sensitivities. One is the change in the economy, because that is what's driving the increasing usage of the network and the potential scale of economic disruption. But the x-axis here is looking at the critical role of the duration of the delay in these calculations, because how long the network is out for, how long those disruptions go on for is a really critical sensitivity in terms of how strong that economic case is for investment in the network. And it also demonstrates how important it is to make sure that the delay is not long, that you have the facilities and arrangements in place and emergency recovery to enable you to get the system back up and running as quickly as possible, because that's crucial in terms of economic recovery. Now, I've spent quite a lot of time in the deeper dives of this talk just now, talking about things which are technical in quite narrow economic terms, I admit. What I've been talking about is a combination of data science, economics, engineering, and what I've tried to demonstrate is that those types of methodology are really now providing the potential to transform the way in which we think about infrastructure networks and go about prioritizing and making decisions around the world. That emphasis on the technical, the economic, the data science is in part because that's the expertise of my group here in Oxford. But from the outset, I've been emphasizing how interdisciplinary the challenges of infrastructure actually are. Infrastructure is as much about people and politics as it is about engineering and technology and the environment. And in fact, across Oxford, we have scholars working on all of those topics. I mean, the purpose of this talk has really been to emphasize what a massive opportunity and often overlooked opportunity and also risk infrastructure decisions represent. And like it or not, infrastructure decision-making is going to continue to be a rather centralized endeavor. There are plenty of opportunities to make it more inclusive, as the French Commission Nationale du Débat Public is a great example of that, of getting people more involved in a more deliberative way in infrastructure decision-making. But infrastructure is still concentrated in a relatively small number of choices. But actually, if we flip that around, that means that it's a particularly influential, if not unique, opportunity to gain leverage on the pathway towards sustainability. And it means that the stakes with respect to infrastructure are really high. This is where things get locked in for decades to come. And I mean, one can dismiss infrastructure as being the preserve of corrupt elites, or you can try and engage with it by whatever means we have at our disposal in order to inform and influence. And I think that's the opportunity that we have to ensure that infrastructure decisions are made more effectively. And I hope I've provided some hints and methods, at least, for how that can be done, which provides the potential for us to navigate a road to infrastructure that takes us towards the Sustainable Development Goals in a measurable and strategic way, preserves and restores the natural environment and ecosystem services. I haven't spent long talking about that, and perhaps we can pick that up in the discussion around how we can develop green infrastructure networks which are alongside it and embedded within grey infrastructure and urban development. The imperative is that infrastructure is at the center of the move to net zero. That starts with the energy system. It goes on to heating and transport. There are challenges along the way with respect to shipping and aviation, and with respect to the materials that infrastructure uses, cement and concrete. Cement and steel. And in order to deal with that, we will have to create a new infrastructure for greenhouse gas removal, negative emissions. And finally, in all of this, we need to recognize that the future is highly uncertain, so we need an adaptable and resilient approach within our infrastructure systems. And I think that is a road worth trying to travel down. Thank you for your attention.
Thank you very much, Jim.
Okay, so we have some microphones. You're going to have to wait for the microphones. But just a word of warning that this is being filmed and live webcast, so if you don't want to be filmed, you have to save your question to the end and come up and talk to Jim privately. So there was one at the back.
Yeah, hi.
Road and Belt Initiative, which is, of course, by far the largest infrastructure investment program that humanity has ever embarked upon. The question is that in assessing any supposed sustainability concerns, how they're going to be addressed, apart from the road and rail infrastructure, port infrastructure, it's accompanied by major investment by Chinese lending institutions for fossil fuel infrastructure. So, what approaches does the international community have that can alleviate the worries that many people feel that what is being put in place is baking in a considerable portion of climate risk for the future?
Yeah, that's a very good question. The Belt and Road Initiative, the BRI, is the largest piece of strategic infrastructure development that's going on. One factoid that struck me is that the BRI investments in Pakistan alone apparently will be total more than the total value of all infrastructure investment in Pakistan since independence. So this is investment on a huge scale, and you're right in pointing out issues both around the transparency of those investments and what they mean in terms of the countries who are entering into to contracts. And indeed, in relation to coal-fired power plants in particular, is a very big issue. So, to be honest, I think there's quite a lot to worry about. On the flip side, if one looks at China at the moment and the level of recognition of the threats of climate change and the amount of innovation that is taking on in China, China needs to be part of the solution as well as part of the problem. The extent to which that is being propagated through the BRI for the time being, I think, remains to be seen.
Yes, I've always been puzzled by the definition of infrastructure. Why, I mean, would it not cover hospitals, preschool facilities, if it's an actual building, or prisons, homeless centers, and so on? Is it because those things? It's hard to measure an immediate impact on growth or economic activity in some way?
No, I mean the definitional question is a very good one, and it's a tricky one. And usually the categories that are thought of are what I've been talking about, which is networked economic infrastructure, so energy, transport, digital communications, water, and waste. And then, as you've suggested, there's a larger category of so-called social infrastructure: schools, hospitals, prisons, police stations. Some people put banking into that setting as well. As you'll have seen, the work which I do is more narrowly defined, and there are some particular characteristics to that networked economic infrastructure which is different to schools and hospitals, in that, well, everything operates as a system. We have a healthcare system, an education system, but networked infrastructure does much more explicitly operate as a system rather than as a series of individual entities. And that brings economies of scale, increasing returns as the network gets bigger. It brings this potential for systemic risk, so network disruption. implies that we need to deal with those networks in a particular way, which is why we've settled on that category. But you're right, that the social infrastructure, of course, is something which we all are concerned about as well.
Can you pass down for me? Thank you.
Hi, thank you very much. Simon Kite. I'd like to ask what the UK should be doing on two particular fronts with regard to infrastructure. You had a graphic on there which was for another country with a nice curve of BCRs and just a small section of them going above 1. But obviously in this country, a lot of the decisions by government departments look for benefit to cost ratio of 2.5 or even 4. Even though some of the major projects that are going ahead in this country have rather poor benefit to cost ratio. Is that what we should be doing, continuing to concentrate on getting a BCR of 4, for example? Or should we be starting with a target for net zero and looking at natural capital and ecosystem services? That's one part of it. And the other is about the balance. You mentioned the kind of concentration and diffusion of decision-making and the difference between, for example, Saint Lucia and what France has been trying to do on a more inclusive decision-making front. How should Britain go about getting that right as well?
Yeah, thank you for that. I emphasized that the narrow framing in terms of benefit-cost ratios is very much a tool. It's a starting point. It provides a means of prioritization when you've got a lot of things which look rather similar in a very big system. If you're absolutely right, though, that there are many different dimensions to this in terms of different values. And if we think, for example, about nature-based solutions, one of the attractions of them is that they bring multiple co-benefits as well as helping us to manage climate risks. So they bring biodiversity benefits, recreation, landscape, and so on. So I think one needs to be very cautious about how you use the tools of benefit-cost ratio and be ready to bring in those multiple dimensions along the way. The next thing you were hinting at is, well, should actually we be doing something more goal-based and then looking perhaps at the most cost-effective way of achieving that goal? And in some instances where we have a very clear goal, like net zero, in a way, this is what the Committee on Climate Change does, is it recommends on what's the best way of hitting the target which Parliament has set. So in that context, yes, but in many other contexts, and if we look at the SDGs as a whole, there's a very complex series of trade-offs, and we don't have snappy goals. And so this is a business of navigating a series of trade-offs rather than just finding the least cost way of achieving a goal. Then finally, your question was about the governance of infrastructure. I mentioned the National Infrastructure Commission in this country, which is an interesting development that is motivated by one well-known governance issue associated with infrastructure, that it becomes a bit of a political football and decisions get kicked back and forth between different administrations when we're talking about systems which take very many years to come into existence. So that's the motivation for arm's length bodies like the NIC and the Committee on Climate Change. The problem with that is the democratic deficit that these types of bodies are seen as being unaccountable. Now, there is, in both climate policy and infrastructure policy, in the end, the buck stops with ministers. So in that sense, it's part of the democratic process. But I think what the French example I referred to is interesting in recognizing that in order to engage effectively in these types of choices, you need quite deep and prolonged deliberation. In a sense, this is what the goal of the Citizens' Assembly around climate change is about at the moment, is to get a cross-section of people thinking about something quite deeply, interrogating data and expertise, getting feedback and conversing around it in order to navigate those trade-offs that I talked about. And it feels to me as though that's the way in which we should be going.
Are there any other questions? There's one here at the front, Clara.
So I was just wondering if you could give us a brief insight into the green infrastructure, which you alluded to at the end of your talk, some of the things that we might be seeing.
Yeah. So the sorts of things we're talking about here are ways in which green infrastructure can either substitute for or complement grey infrastructure. The sorts of things we're talking about are with respect to flooding and drainage. So sustainable urban drainage is the term that's often used, where rather than putting water into pipes, we put it into swales or wetlands or ponds and enable it to infiltrate naturally, and that also has benefits with respect to water quality and natural purification of water. Or we might be talking about larger scale natural flood management at a catchment scale, which can help to retain water up in catchments. We might be thinking also about urban cooling and vegetation on a large scale in catchments, which also helps to deal with water quality issues. So addressing diffuse pollution rather than then having to clean up that water in water treatment works. The idea of nature networks, which I touched on at the end, and this is part of government policy now, is the development of nature networks. It's quite embryonic. But I think that the direction of travel with that should be that we map out the networks and spaces for nature at a national scale in the same way as we map out our physical infrastructure, and try and prioritize that and prioritize the restoration and completion of those networks as part of building development and infrastructure development. And it may be that we can embed those nature networks within urban development, as well as conserving and restoring spaces in rural areas. So that's really what I'm getting at, is this kind of move towards co-development of green networks and grey networks, some of which will be in rural areas, and some of that green will go right through our urban areas and will be alongside and part of our grey infrastructure.
David Hendry, you talked a lot about data, and you're obviously using a lot of satellite data, but our partner, Climate Central, has recently shown that satellite measurements of the height of coastlines at the sea edge is wrong by about 4 to 5 meters around a lot of the world. And it's wrong in the wrong direction, because the satellites have been bouncing off the tops of trees, the tops of houses, and other things, not off the actual level of the coast where it hits the sea. Now, I do wonder to the extent to which, when you're designing infrastructure, you can do much more research on the data and not just take measurements as if they were in fact correct. Now, Climate Central spent 3 years developing new measures using LiDAR to actually see what is the height at the coast. And it turns out about 500 million more people are going to be subject to flooding on the basis of the estimates that they've come up with from what is actually the height where the ocean hits the land. Never mind the fact that it's rising, that cities are sinking, that the coastline's being eroded. It's quite worrying that infrastructure development around coastlines, and a lot of your coastline in Thailand is, some of it's quite low, some of it's quite high, but one does worry a lot that the accuracy is much more important than I think is being ascribed at the moment.
Yeah, we're very much people who do as best we can, and we're always on the lookout for new and better data sets, including with respect to digital elevation, which, as you say, is so crucial for flood modelling, including on the coast. And you're absolutely right also around coastal infrastructure. Some of the trickiest questions with respect to adaptation exist on the coast. So how do we decide and where do we decide where to let the natural submergence and retreat of the coastline proceed, because that is what coasts do when the sea level rises, and they're inherently resilient in that sense. Or where, on the other hand, is it going to be necessary to invest more, and it will be necessary in the future to invest a lot more in order to protect coastal infrastructure.
Hi, Mark Cowell again. Concerning HS2, we have a substantial investment, just somewhere around £100 billion over a large extended period of time. What are your views on the role of this kind of mega scale of investment, considering all the varied kinds of impacts it will have, for example, on the woodlands and different spaces that are important for biodiversity along the route? Do you think it's worth the effort? Is it rational for these times?
Yeah, one of the things I said in passing is that in the face of uncertainty, one in principle is better off doing things which are incremental and scalable. And on the other hand, something like HS2 is a massive bet, isn't it? It's about as lumpy as they get. So HS2 was always going to be an extraordinarily difficult decision, in part because this bet is based on what I mentioned at the start around economic geography. And so how will a piece of infrastructure like that change the spatial structure of our economy? And those are the things which are most difficult to predict, because they depend on lots of other things which will go on in the meantime. And then there are questions around the trade-offs, the impact on extraordinarily precious pieces of the natural environment, whether the money could be used better for other purposes. But when I asked my daughter about this, she just said to me, well, Dad, if we're going to be flying less and driving less in the future, then we've got to do this thing, haven't we?
Okay, that seems to be a good
note to end on. Before we just close finally and thank Jim again, I would just like to urge you to check out the other talks in our series. It's every Thursday at 5 o'clock in this room. It's the series is on shaping the future, and it covers a huge range of issues from infrastructure right through to health. And next week we have Professor Malcolm McCulloch who runs a program at the Martin School on integrating renewable energy, and he is talking about powering the future, switching on the renewables. But I'd now just like to close with one final thank you for a really stimulating hour. Thank you very much, Jim.